Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you're watching live or you're watching the recording, I appreciate you watching. Thank you for joining me today. So today we're talking about digital color, and digital color is one of my favorite subjects. I could probably do an entire course on digital color just to let you all know as we're getting started today. Digital color and color theory and just understanding how color works in general. You know, it's pretty important to talk about this sort of stuff because, well, we don't really get anything like that, right? Like, we don't really get any information about kind of what color is or how color works. You know, we're just kind of expected to know, like, what colors go together and what colors work and this and that. And oftentimes, you know, it just kind of leaves us guessing, which not the best thing to do, right? Just guess at what colors that we should use. Or we end up just picking bad colors, or we end up really not using any color at all. Like, we just go black and white and gray, which is color in and of itself. So I want to talk a little bit today just about digital color, how color works, and we'll talk a little bit about color theory, which is sort of the basis of what's in our module. So when we're working with digital color, what we're working with is called the RGB color model. That's RGB, red, green, and blue. And it actually kind of takes things and makes them or it kind of takes the things that we know, right, when it comes to color that we learned when we were in like grade school, and it turns them on their head because it's a completely different color model. Right, when we are in, like, say, kindergarten, first, second grade, right, and they're teaching us about primary and secondary colors, right? We learn about primary colors being the basic colors that just have to exist, right? They cannot be created by mixing two other colors, or three other colors, or multiple other colors. And in kindergarten, when we say these are the primary colors, we always talk about red, green, and blue. And insofar as all that goes, like, it's technically true, right? Kinda. You know, when we think about, or it's actually, flip that and reverse it. I'm getting ahead of myself. In kindergarten, when we think about primary colors, we think about red, blue, and yellow. Red, blue, and yellow, right? Because, like, red and blue make purple, yellow and blue make green, red and yellow make orange. And to a degree, that is correct, right? It's correct insofar as, you know, really what we're talking about here is color mixing and color theory. So let me get back on it. The elementary school color theory stuff is, you know, the red, yellow, blue is for paint, right? And really, even then, it's not quite right because it's technically the cyan, magenta, yellow, which is just kind of a different version of red and a different version of blue. Just, you know, we don't tend to teach 5-year-olds about cyan and magenta. when we're talking about light and digital color, we are talking about the RGB color model, red, green, and blue. And so these are our three primary wavelengths of light. Right? So they're the three primary colors that are done by wavelengths of light. And if you all will give me just a moment here. Sorry about that. Too much stuff trying to grab my attention. So the RGB color model is our digital color model. And it has to do with wavelengths of light. Red light, green light, and blue light. And these are our three primary wavelengths of light. And I actually have some flashlights that demonstrate to us what the picture here is showing in this slide here when it comes to our digital color theory or additive color mixing. It's what we call mixing different colors or different wavelengths of light. And so we can see here in this graphic that in the area where the red and the green overlap, we get cyan light. In the area where the blue and the red overlap, we get magenta light. In the area where the green and the red overlap, we get yellow light. And where all three overlap in the center there, we get white light. And so we can kind of see this color mixing here as represented with light or flashlights, which is kind of what this is trying to represent in this graphic. And if you ever have gone to like a theater where a play is happening and you see the light on the stage, you can tell that the light is mostly bright white light. But if you were to look up at the lights in the ceiling, you would see that most of them have what they call gels over the top of them. And these gels change the color of the light. And the color of these lights are red, green, and blue. And so it's just that when we mix them all at the same intensity, that makes white light. And it's when we start to vary the intensity of these different wavelengths of light being projected onto a surface is when we get different digital colors. So for example, I could be showing, I could have twice as intense red light as I have green light. And that's something that we could do. Another thing, too many distractions this afternoon. Too many distractions. Sorry. If we had twice as much red light as we did green light, it would make something in the orange family based on the overall intensity, right? Because we can see we have yellow when we mix equal amounts of red and green. Well, then if we jack up the red even more, we'd have some yellow with some red, which we know makes orange. And so from there, we get the thing that we are kind of used to, or we kind of get the foundation of the thing that we're all kind of used to, which is the RGB triplet. All right, so we get three different values of numbers: red, green, and blue. And each of those values there, we get intensities from 0 to 255. So our triplet is 0 to 255 red, 0 to 255 green, and 0 to 255 blue. And when we think about the numbers here, we're basically thinking about the intensity level. So 0 is absence or no intensity, and 255 is full intensity. And so we could have any number there in between. From 0 to 255. For example, I could have, 180 in red. And that's just a different intensity value. So it's kind of taking it and it's shining it down a little bit lower. Right? Think about it like a flashlight. If you had a slider on the side of a flashlight, you could turn it all the way up, that's full intensity. And as you started to dim it, that's just dimming the intensity. So the lower the number, the less intensity, the darker the color, and so on and so forth. Right? And we look at these lights on a spectrum. Right? The spectrum here based on wavelength. So we see that red has the longest wavelength, green has the middle wavelength, and blue has the shortest wavelength. And that's actually why the sky is blue. It's because that's the wavelength of light that can pass through the atmosphere. So we can get these different intensities and these different wavelengths, and we can mix them together, and we can get a full spectrum of colors. And so we don't necessarily always talk about color in that sort of way. Right? Because typically when we're dealing with color, we're dealing with what some people might call, say, hex color. Right? You might see a color like hashtag 97B281. And these are those RGB triplets that we just talked about. They're just expressed in a bit of a different way. So for example, my first two numbers here, these are my red values. My second two numbers here, these are my green values. And my final two numbers here, these are my blue values. So if we were to represent them out, 97, B2, 8, 1. And so these are those same numbers from that RGB triplet that we were just talking about, or the RGB, those three RGB intensity values. We just wanted to be able to do it in a shorthand that would allow us to write the color more quickly and easily. And so we come up with this hexadecimal color. Because in hexadecimal is a base 16 numbering system. Whereas what we're used to is a decimal number system, right? Decimal numbering system goes from 0 to 9, so you have 10 digits. Hexadecimal goes from 0 to F. Because numbers after 9 don't exist in our numbering system, right? They're just using two or more numbers of other numbers that already exist. Right? Like 10 doesn't exist. It's just a 0 in one's place and a 1 in the tens place. Right? So we had to come up with another way of being able to express numbers in a hexadecimal format. And so that's why we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And it follows out that way, right? It's like basically counting to 15. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Just we have to have a different character to represent 10 through 15. So we use letters. Right? And so if we break this down, we can actually determine where we're at. Based on converting these numbers, we can determine that intensity of that value from 0 to 255. Converting to hexadecimal is relatively easy, right? Because we're only converting two places. We're converting the first place, which is the 16s place. Or actually, it's the ones place. And the second place, which is the 16s place. Right, because this is how we denote our places. Right, the first number, the number on the right-hand side of the pair of numbers, is in the ones place. But we determine that by its 16 to the 0. Right, anything raised to the 0 power is always 1. And then in the next place, it goes 16 to the 1. If we had a third number, in a hexadecimal number, it'd be 16 squared. Fourth would be 16 cubed. Fifth would be 16 to the 4th. So on and so forth. But since we only have a pair here, we can just worry about this. So for example, our red value here, what number is in the ones place? Well, it's 7. What number is in the 16s place? Well, it's 9. So all we would do is we would take the number in the ones place, multiply that by 1. We'd take the number in the 16s place, we would multiply that by 16. Then we'd add those two numbers together, and that gives us our value. So 7 times 1 is 7. 9 times 16 is 144. So 144 plus 7 is 151. So our red intensity value in this hexadecimal color is 151. For the green here, the number in the ones place is 2. The number in the 16th place is B, which corresponds to 11. So we do 2 times 1, which is 2, plus 16 times 11, which is 176. So that is 178. And then 81 accordingly. 1 plus 16 times 8. 16 times 8 is 128. So this would be 129. With the highest number in a pair being FF, which is equivalent to 255. So if we saw hashtag FF, that is full intensity all the way up of red, green, and blue. And as we saw in our graphic from the previous screen, if we have full intensity in equal parts of red, green, and blue, it's white. So FF is white. 00000 is black. And we can go with that accordingly. If we were looking at our hexadecimal color here, based on these intensity values, we could have somewhat of an understanding. And this is a really ugly color that I just pulled out of the air. But we can have somewhat of an understanding of basically how or what this color is. Because we can see that the dominant color here, the color with the most intensity, is green. And then we have just slightly less equal parts green to red. And then slightly less than that is blue. So green's our dominant color. It's not full intensity, so it's a little bit darker. It's actually a lot a bit darker, right? Because it goes to 255. So it's about at 75% intensity here, maybe even a little less, maybe something like 60% intensity. Our red is basically just above half intensity. Our blue is at roughly half intensity. So we'd have kind of a pink-ish color plus a lot of green. So a lot of that would cancel out. So we'd end up with a lot of green and red, which would give us a yellow, but it's brown because it's a little bit darker. Add a little bit of green to it. And this is going to be like a really bad kind of, I think it's going to be kind of a bad or a tough sort of weird kind of dark green color. Let's Google it and find out here. Let's see, we did, what was it? 97B2 81. I lost it. And actually, that color's not as bad as I originally thought it would be. I mean, it's almost technically, like, it's almost one of the colors that's in our sidebar here underneath the, our color's a little bit more saturated. It's in our background here. So if we kind of look at our sidebar here, which is where the chat would go, on this darker colored bar here, it's almost that color. Which is kind of interesting. And that might not be exactly the right color there, because believe it or not, I forgot from showing the color to having the color on the screen. I was more afraid that it would be in this sort of territory, which would be pretty close, which is a little bit tougher. But we can see that's pretty close, right? Like we can at least get in the ballpark based on the intensities of the different colors that we know. And so all of that is just to kind of get us into a place where we could talk about color theory and color wheel terminology. And so when we look at colors on a color wheel are referred to as hues, right? And there are millions of different hues that we could use to be able to work with a website. Black and white and gray in color theory, since there's nothing that has any more intensity than anything else, it's considered neutral. Right? So we call those neutral or grayscale. There's no dominant hue. Now, some other terms that we could use here. Would be complementary colors. And so when we look on a color wheel, colors across from one another are considered to be complementary color wheels. So we can see here like a cyan and orange, like a purple and a yellow, red and green, magenta and sort of a lime there. They're considered to be complementary. If they're next to one another on a color wheel, then they're considered to be analogous. Right? So like this purple and blue, this magenta and purple, or magenta and red. And so when we start to think of colors on a color wheel, we start to think about the relationship between these different colors and how we can use them. And one of the things that I oftentimes like to do is I like to use a different type of color in HTML, or really in CSS, because it just makes more sense to me. and that is HSL. So we're typically used to using hex color to pick our colors in CSS, but hex colors, they're not really intuitive, right? Like we saw that process there that we had to do to sort of understand what a color is. But with HSL colors, which HSL stands for hue, saturation, and lightness, it works a lot easier. Because I know that when I'm working with a circle, I'm working with a 360-degree circle. And so when we're looking at a color wheel here, we know that, well, it goes around in a 360-degree circle. So this is our HSL color wheel. And so it might just be just as easy for me here to just start to work in this and use a website file here. And I'm going to do something interesting with this. Let me switch over to full screen here. I am going to add my HTML skeleton. And instead of putting the style in the head, like I normally do, I think what I want to do here is put it in the body. Now, let me think about this for a second. No, I think I can put it in the head. Because we're going to do something that's kind of interesting with this, because one of the things that you can actually do is make style tags content editable. So while the website page is up, we can actually make edits to it on the page. What I'm going to do here is I'm going to do head, title. I actually don't think I need title here, but I think I can do head and style. Display block to show this on my page. And then we can save. And I'm going to open up that file. And you don't have to do any of this. This is just me setting up a file here to do something interesting with it. So now we can actually see my style code here. And if I were to add something like font family sans serif, is this not going to work? This is supposed to work. Let's see, what am I not remembering? Maybe I just need to do it to where I'm putting my body color in here. And let's make it red. So in HSL, we'd go HSL. Red and HSL. Color wheel is 0 or 360 because it goes all the way around. And we'd go 100%, 100% lightness, 100% saturation, or flip it and reverse it. I actually wouldn't want 100% lightness because that would make it white. So I'd want like 80% lightness. Or maybe even like 50% lightness. And so when we look at that, it would help if I put things in the right place. When we look at that now, it makes a red. Right? And so if I want to go 60 degrees around the color wheel, it makes a yellow. Right? So it's the exact same color. It's just now we're going around that color wheel, right? You remember we had the color wheel. Let's just let it peek in here. Red's at 0. We went to 60, and now we have yellow. If I go to 120 here, I should expect green. 180 here. Here's our cyan. 270 is like a purple, right? So that means that like 320 should be like a magenta. Right? And it's just following around our color wheel here. And if we move sort of 60 degrees at a time around our color wheel, we hit our big colors. And so if we want complementary colors, we can actually move around our color wheel in a bit of a different way. And you can actually see here that complements in this method are a bit different than they would be in other types of color, right? Because we look and see what colors are directly across one another on the color wheel. So in this instance, the complement of red is actually cyan. So if I wanted to, I could do something kind of interesting here. Like let's set some variables. Let's set some CSS variables here that would allow me to make complements. So let's make a couple variables here. On our root pseudo selector, we'll make a main color variable and we'll put that at like 0. And we will make a complement and we'll put that at 180. So now if I had an H1 here, make that hello world. And we have a H1 element selector here, and we color HSL. In this instance, what I might want to do is say var complement. $100 50%. Right, so by default, we'll just use, we'll start with red and green here. Var main color and complement. And we can see what we end up with, right? Our main color is 0, so the background is red. Our complement is 180. Well, what if we did something like this? We used a calc function and said calc, and we made our complement calc var main color plus 180. So now it'll always be within 180 degrees. So as long as our main color doesn't get above 180, our complement will always work. Right, so we can always have a complementary color. So now if I change this main color to be, say, 60, where it's yellow, you can see that my complement changes to this blue. If I change it to 120, my complement changes. Right, and so this is a great way for you to be able to start templating colors and working with colors in that sort of way. Right, since we're using HSLs here, we know that HSLs, if we're dealing with a complement of an HSL, it's always on the opposite side of the color wheel. Half of a circle is 180 degrees. So if we go 180 degrees from our main color, we have a complement of that color. So if, say, it is 104, we get that complement. And we can even start to play with our H1 color a little bit, right? Like maybe we want it to be a little darker. So maybe we want our complement to be a little darker so it has a little bit more contrast. So we can say, oh, well, just give me 50% of that then, instead of 100. Just give me, well, that's saturation. I want 100% saturation there. But let's take that down from, in lightness, from 50 to 20. Right, so now you can just barely tell that it's purple. Right, but if I changed my color, it's going to change things dramatically, right? Like if I change it back to red, you can see that that's a dark blue. Doesn't look too great against a dark, sort of a darker color here. We want to be able to push contrast here. What if we made that lightness a lot lighter? Looks good here, right? Might not necessarily look good on all backgrounds, though, right? So if we just set them both the same, use the same complement, we can have a complementary color that's just automatically calculated. And we can try different color schemes, right? 30. Orange and blue. Right? And maybe that blue's a little bit too light, not enough contrast. Right? Contrast is one of the big important things that we'll talk about a little bit later on in the course, so I can make that darker by adjusting the light value there. And so now it's a little bit darker. I could change the lightness values of the background color and make it a little bit lighter. Right, and all of a sudden we have complements that work together on the color wheel, but now we've created a little bit more contrast. We're starting to make things pop out a little bit more. And it's all templated, right? So, we could do this for one project and use these colors. For the next project, we could change it around completely and use some completely separate colors, like maybe green and blue, or maybe even red and cyan, or just whatever we're dealing with. We can basically turn whatever color that we want to, since we've created this template here, and make an infinite number of color combinations just by changing one value here. And we always get the complement. Right, another option here would be to do a triadic color. Right, so let's say I put this H1 inside of a main. And so a triadic color is going to be colors that are 3 spaces across from one another on the color wheel, or 3 colors equidistantly spaced across the color wheel. So these are all, would all be 120 degrees. So let's add our main selector here. We'll add a dash dash triad here, and we'll let that calc var complement var complement plus 120, and we'll change this to be 120. So we have 120, so this color plus 120, and then this color plus 120. And so then main becomes background color HSL var triad. And since this is the main, I want it to be a little bit lighter. So we can kind of play with the colors here, right? So it's 100% saturation. Well, maybe we want this to be lighter, so we can say 80% lightness here. We'll also add like min height of 600 pixels, margin 0 auto, right? Just so we can do a little bit of a demonstration here. The body can be darker, so we can make that, the lightness on that go down. Let's say it goes down to 30. And since the H1 is a darker color on a lighter background, we can leave it at 50. In fact, let's take this body and make it go back to 25. And so now we can see some triadic color schemes in action. And your course actually talks about a lot more of these different types of color schemes. Right, and so this is our default triadic color scheme that we're given here, and it's pretty ugly. Right, but if we try to, if we just start to go around the color wheel, we might find something that's kind of interesting. We might not. We might need to manipulate these colors a little bit. Right, maybe we need to take our maybe we need to take our H1 and make it a little bit darker. Maybe we need to take our background color and make it a little bit lighter. Maybe we might even want to give it a width. Just so that makes more sense. Right, so now we can just kind of go around the color wheel going 60 degrees at a time. So 0, that's what 0 looks like. That's not awful. Well, 60. That's what that looks like. Not a big fan of that. Maybe let's try 45. 45 looks kind of interesting. Right, and typically we wouldn't necessarily use a triadic color scheme like this. What I might do instead, if I were to use a triadic color scheme, is I would make, like the main, I would make it white, and then I would have something else that was a part of the main. Like I might say background color is white, but maybe border dash bottom is 20 pixels solid HSL triad blah blah blah. And then at that point, we can make it a bit darker. All right, so H1, let's just make it text align center. And now I can just go around the color wheel, testing things out. There's 60, there's 80. That's pretty good. I kind of like that as a triadic color scheme, right? You got a nice, it's sort of a nice garden vibe, right? A nice dark sort of text color here. I like that pink against the background. Looks pretty cool. Let's try like 120. That's what 120 looks like. I like that too. 160. Ooh, that's a pretty cool scheme. Right there, right? So we have a triadic scheme that's using 3 different colors that are equally distant from one another on the color wheel. We have it templated. And we can see how it kind of works. And what's interesting about this to me is, sometimes things work and sometimes things don't, right? Like if I were to look in, if we were to look at the different types of color palettes, and we'd see like a monochromatic color palette, and we'd see our complementary color palette and our triadic color palette and all these different types of color palettes. Typically what we see on websites the most often are going to be complementary colors with white and black, or a monochromatic color palette, which is all shades of the same color. So I would use the same hue value, but vary my lightness values. And I think oftentimes that's probably the way that gets us, some really nice stuff. Right? Like if I were to just do this here to where we just say, oh, well, this is going to be this and this, we'll just do that just so like we can change it back really easily. Now all of a sudden it's in a monochromatic color palette. And so we can kind of bring that back. Let's make this like a width of 60 VW. Let's make that color be border bottom and have it at like 20 pixels solid, that. And then background color white. And then all of a sudden we have a pretty interesting monochromatic color palette, right? Nice dark background, a lighter accent color here on the bottom, and this sort of medium color that we're using for our headings. And we can, again, go around the color wheel. And see how different colors work. And especially with some of these colors, we see that, we probably want to push contrast a little bit more. Like our H1s for a lot of these, not quite dark enough. So we might want to push contrast just a little bit more. So we'd make the lightness on our H1s just a little bit darker. Like say 30%. We can make our background even darker, right, to give even more contrast. And so then, things make a little bit more sense, right? They give they're more it's more contrast, it's easier to read, it's nicer. And so what I'm going to do here is I'm actually going to put this, I'm going to leave this like this. We're going to call this the triadic color tester. We'll put a paragraph in here and say like test triadic color palettes by editing the CSS above. Let's just make this a little bit nicer, and I'll put this on GitHub and share it with everybody when I post the recording. But I do think one of the big things out of this is to kind of get this, if we're going to use HSLs, which we like, which we talk about in the module, I like using this variable system to create color palettes. It's easy. And I can change entire color palettes on the fly. Obviously, having my style here is just a gimmick. It's just a gimmick here to have my style content editable, just so you all can see and manipulate the colors just a little bit easier. But it is pretty cool, right? And it's something fun to play with. And I encourage you all to sort of play with color and test things out. That should be test and not text. And let's put a little bit of padding on main. Let's add like a little bit of stuff like box sizing, border, box, font. Actually, I wouldn't want to do that there anyway. Let's do that on the body. Box sizing, border, box, font family, sans serif. And there we go. Now all you have to do to play with this is to just change the main color. And you get to see different triadic color palettes. You can also change the lightnesses and the darknesses and all that kind of fun stuff, and just see the different color palettes in action. And so with that being said, that's all that I have for you for today. I think I am... Yeah, it looks like I'm all alone today, so we'll go ahead and wrap things up for today. That's all that I have for you for today. Thank you for watching, and we will see you next time.